Let's join Thandi Maseku from CTC as she shows us the wiring of the power circuit for the forward or reverse single-phase starter.
I'm just going to give a brief breakdown of what we have in front of us. In front of us, we've got what we call a power circuit, which we use to control the motor. So now we've got a contactor that is going to be used for forward and a contactor that's going to be used for reverse. We have wired in cables that are going into the motor. Remember, all the time we need to connect between the motor and the contactors for us to be able to have continuity. So we've got a connection that comes from the running winding, which is where we're doing the reversal of the direction. So we're coming in from the motor, and then what we're doing then is bridging from the forward contactor into the reverse contactor. And if you can maybe just have a look, the fact is that we are swapping a live and a neutral on each side so that we affect the direction of the motor. I'm gonna demonstrate how that gets done. Bear in mind that the color coding is not correct. What I should be having here is a black conductor, because for neutral we can use black when we do hard wiring. We only use blue when we are using a flexible cable, as in this case currently.
Let's take a detailed look at how this power circuit is wired. To start with, we have live connected to L1 of the forward contactor. This is bridged to L2 of the forward contactor and L1 of the reverse contactor. Next, neutral is connected to L3 of the forward contactor and bridged to L3 of the reverse contactor. T1 of the forward and reverse contactors are bridged and connected to the centrifugal switch of the motor. T2 of the forward contactor is bridged to T3 of the reverse contactor, and then both of these are connected to the start of the run winding. T3 of the forward contactor is bridged to T2 of the reverse contactor, and then both of these are connected to the end of the run winding. It is this switch over between T2 and T3 of the contactors that switches the direction of the run windings and hence the motor's direction. Finally, the end of the start winding is connected back to L3 of the forward and reverse contactors. Now let's go back to Thandi as she demonstrates how this main or power circuit works.
So I'm going to put the power in, and what I'm going to do is not allowed to be done in terms of running the contactors, because the sooner we push the contactor in, we enable power between the inside, the supply side and the load. Now with my hand in this vicinity, if you do that, there's a chance that you can get electrocution. So what I'm going to do is not allowed, but for the sake of the demonstration right now, I will do that in order to show the connection that is in here and the effect it has on the motor. So right, if you recall, initially when we had the power plugged in, we would have had motion on the motor, and as you can see, there's nothing because control now has been given over to the two contactors. So I'm gonna push the first contactor in, which is a forward contactor, and note the direction of the motor. So we have got motion on the motor in a clockwise direction from where I am standing, and I'm then gonna push in the reverse contactor, which is now turning in an anti-clockwise direction, showing that the direction on my motor is changing using the effect of the contactors. But now remember what I said, you're not supposed to bring the contactors in, bringing your hand here. We can make use of a stop and a start station, which is what we have over here. Now, auxiliaries in electricity works a lot. They almost basically become the heart of what we do as electricians. Now, we have got a normally open auxiliary. It does exactly the same as a normally open auxiliary over here. But what I'm doing here is going to be using the start button to close the normally open. That will enable power to the coil, which will then allow direction or motion of the one contactor.
Now that we have our main or power circuit complete and working, we can shift our attention to connecting up some motor controls. In this case, start buttons. Once again, let's see Thandi demonstrate how to connect these.
And for me to stop, I would need to use a normally close. Remember what I said, a normally close in its normal de-energized state. I've got continuity between the 2 points at all times. So even here, there's always continuity between these 2 points. So once I've connected them up, I would have power even if as soon as I close my circuit, so that I've got continuity to whatever I want to do. So if I press my normally close, I disable a circuit. So in this instance, I'm going to be using a normally close as a stop button to stop whatever motion that I've got on the motor, whether on the reverse or on the forward. I will use a normally open to bring in motion on either of the contactors. Now we're going to start wiring in our control circuit into the contactors, merging the main circuit and the control circuit. So we're going to do things the correct way. I'm going to start wiring in my A2 sides onto the neutrals of each contactor, because in a 220 circuit, as will be shown on the sketch for you, your neutral is always common and it runs across all your contactors that we're using. So bear in mind that the color that you're supposed to be using of the correct wire is supposed to be a black wire. So for this demonstration, I'm just gonna use red. So I'm connecting the A2 of my forward contactor. I'm gonna be giving it a supply neutral. The neutral on my forward contactor is done. I'm gonna repeat the same for my reverse. One thing with electrical connections, you've got to always make sure that your connections are tight. You don't have a loose connection, because it creates a spark and it's something we don't want. So I'm going to be moving over now to the control circuit. Remember, we are using the normally open of the forward, which is our start button, and the normally open of the reverse, which is our start button number 2. Now, as you can see, I've got numbers that are allocated here. I've got a 3 and a 4. So I'm going to use the 3s as going in. I'm only going to bring in one supply from the live side into only one of the 2 auxiliaries. And I'll use this bridge piece to connect between these 2 points. Okay, now that I've wired the 2 supply side of my start buttons. I'm now gonna go out of each individual start button. I'm gonna start with the reverse one. It has got to come onto the supply side of my coil in order for my coil to have across it 220 volts. So remember, this is my reverse and it's the top one. So it's gonna go onto my A1 of the reverse contactor. And for this purpose, wire in the last bit. This bit is on the forward, so I'm gonna go into my A1 of the forward contactor. The way our circuit now is connected is both our starts are having a supply that is connected, which is our live. We're going out of both the start button into the respective contactors. So by right, when I press the reverse start button, the reverse contactor should energize. If that energizes, according to the wiring that we still have in place, the motor will run in the reverse direction. So I'm just gonna put the cover on so that we are able to use the start buttons the right way. With the supply connected, I'm gonna start with the reverse contactor. So this contactor should come in and not this one. As you can see, our contactor is engaged because we've got the voltage. The circuit is still in place. Our motor is running in one direction, and if I let go, it de-energizes. My motor comes to a stop. Now I'm going to engage the forward direction. This contactor should come in. As you can see, the contactor is energized. Our motor has changed direction, and oops, I've got to let go because I'm tired. Electrically, this motor is working, but the circuit is not completely functional, because you cannot have a person standing by and pushing the start button all the time. We need to make a plan to be able to make sure that we keep the circuit in when the start button is pushed, and we'll move that onto the next segment of our wiring.
Let's draw the control circuit diagram of the circuit we have created so far. When wiring control circuits in installations, we always need to add circuit protection. This should consist of short circuit and overload protection. Now, we can complete the rest of the circuit. We start by indicating the connections to the live and neutral supply. Next, we add in the forward and reverse contactors. Remember to label these as F and R for forward and reverse. Now, we can add in the two start buttons. Remember that these are normally open push button contacts. Make sure that you label them as start buttons.